Hello and welcome to another episode of the AI Show. My name is Seth Juarez. Howdy doodle! By the way, we've got a great show today, I think. It's just me. So I don't know, how good could it be? I don't know. Today we're going to look at prompt flow. It's something I've been not putting off, but I've been trying to make like the perfect video, and I realized that the only perfect video we're going to make about this is one we make together. And so that's what we're doing today. So we'll start first. Where's everybody coming from? Say hello. I'd love to say hello to each and every one of you from wherever you are and wherever you're visiting from. But again, today's show is all about prompt engineering using Azure AI Studio's Prompt Flow, a brand new end-to-end prompt engineering tool. From prompt construction all the way to deployment and monitoring, Prompt Flow has everything you need and more. Wow, I sounded like a commercial, and I'm biased, obviously, because I work on it. It's something I work on together with a ton of people. So where is everybody coming from? And as everyone is saying that, I am going to go back to this handy dandy tool. By the way, my desktop was broken for a while. I stayed up late last night and fixed it. I had to replace the motherboard. And so I am now on my brand new spanking new machine from the new machine, old machine. And I don't have everything installed. But 100%, this all happens inside of a browser. So I'm pretty sure that's the case. We'll find out today. Today we're going to look at the basics of prompt engineering with Azure AI's Prompt Flow. And here's the order of things, as you all tell me. By the way, I got my Wacom tablet to work again. So I'm writing with my actual, this is my actual handwriting. We'll start first with talking about like, here, let's delete this. Let's delete this like this. We'll start first with talking about like, here's the order of things, and we're probably gonna run out of time, so I'm gonna have to do this another week. Number one, why, what, how, LLMs. In this case, we're using ChatGPT. What is this thing? How does it work? Etc. So that you know what the job is, because I think the problem is most people with prompt engineering just don't know what it is that what's the job? Like, what is it that we're actually doing and why? And there's going to be some opinions that I have that I'm going to tell you. And then there's going to be some things that that's the way we do them in Problem. So that's the first. Number one, why, what, how, LMs. Number two, what? Oh, jeez, I'm so bad at this. It's like, maybe this is why computers were invented. So what is the task? We're going to talk about that. Number three, we're going to go a quick intro to PF, prompt flow. I'm going to call it PF from now on. Then we're going to talk about for runtimes plus connections, and then 5, we're gonna build a PF. My sense is we're gonna run out of time at that point. Were we to continue, I would show you how to test a prompt flow, bulk test it, and then do evaluation flows. After we do evaluation flows, we would look at get metrics, and then after that, I'd show you how to do deployments and monitoring. But that, I think we're going to run out of time at number 5. And so that's what we're up to today. That's what we're doing. So let's see where everybody's coming from here. Where's everybody coming from? And I'll put my... Okay, we've got a lot of people here today. I'm excited to see you. I spent some extra time tweeting out and putting on the socials that I'm doing this today because I want everyone kind of has been asking for this stuff, and I feel like I have neglected it. So hello from Singapore. Hello, my friend. How are you? Lovely place. Abu Dhabi. Welcome, UAE. I've always wanted to go to the UAE. Fascinated by the Arabic language, incidentally. San Diego, California, from LinkedIn, land of my birth. I was born in the San Diego, Milwaukee, Wisconsin. You betcha. Okay. Another Microsoft product with flow in the name. It's not a product, it's a feature of Azure AI Studio. So there you go. Javier from Spain, bienvenido, mi amigo. Yo viví en España por unos años en Málaga y Sevilla. That's my Spanish. New Jersey, the melting pot of the United States. There's so many different kinds of people in New Jersey. It's fantastic. Turkey, welcome. Taiwan, welcome. India, lovely place. Oh, it's Cassie. Cassie needs like a walk-on music whenever she's here. I don't know what I should pick, Cassie. Cassie's awesome. Boston, Mass. Toronto, Canada. South Africa, welcome. From France, bienvenue mon ami. Sheffield, UK. So we have a good smattering of people from everywhere. What I want us to do, there's so many folks here. What I want you to do is, what is this stupid music here? Fast forward here. What I want you to do, we have Arizona, Argentina. Paul, I would like to protect myself against prompt injection. Great question. Argentina, Microsoft has been good to me. Nice. Serbia, ATL, Argentina, Istanbul, Philly, lots of folks. So what I want us to do is I want folks to ask questions as we go throughout this, because really it doesn't really matter what I have to say. It only matters what you understand. And so if you don't understand something that I've said, it's not because you're not capable of it. It's because I'm a bad teacher and I need to explain a different way. So feel free to do that. We don't need to be full screen here, but there you go. Denver, Colorado. Hello, my friend. So this is what we're going to do to start. So let me do this. Let me start first with this important thing here. What, why, and how for LLMs. I'm going to be brief because I've done this a number of times with you all. And I want to make sure that I repeat it over and over again, because I think there's a general misunderstanding for what these models actually do. And now we're talking about ChatGPT and the model itself. So what these models do is they take, in the case of ChatGPT, 4,000 tokens. And if you're wondering what a token is like a piece of a word, a piece of a word, like a couple of characters. So I'll even show you, because I'm like talking here out of. So if I go Open AI tokenizer, right? You'll see that even OpenAI is super nice, and they add like the tokenizer. So, Windows H, yes, let's do that. Let's talk about a couple of things, and let's see how these are entered and tokenized. Thank you. Look at us using AI all over the place. Okay, so you can't see this because I'm looking at it. It's super small. This is what I just like. Come on. I forgot to put Zoom It on my machine. I knew I forgot something. Zoom It. Brand new machine. Download Zoom It. If I don't have Zoom It, I cannot. I knew I forgot something. So this is the thing I forgot. So let me do this. I always make like a util folder on my machine. So we're going to right click, open in new window. Sorry. And then I'll make utils, new folder, util. Thank you. And then we're going to take Zoomits, all of them, and we're just going to dump them into my util folder. Thank you. I wanted to originally, is this A and right? I'll just do this one. Agree. Okay. Okay. Now we are ready to go. Thank you. Thank you. Okay. So now you'll see that this is just text that I've like spoken in, but these things are broken up into tokens like this. So for example, this token right here, let me lower the music down. Notice how there's a apostrophe S repeats itself a lot. So it becomes a token. Otherwise, if we have this as a token, then we'll also have to have like other words like Seth's token, and then there's too many tokens. And so notice that tokens are basically pieces of words. Sometimes they're entire words, and that includes the spaces. Okay, so that's what I mean by tokens, and that's hopefully pretty clear. So given 4,000 tokens, what this thing does is it puts those tokens through a model. We're going to make the model this little box. And what comes out of this thing is just one token. So that's what these models do. So that's what this does. And you're like, but Seth, please. I have seen ChatGPT type at me a bunch of stuff. Well, it turns out, man, I'm all over the place today. It turns out that what it does is once you have one token, it will take that token, right, put it here, and then it will take the other, 3,999 tokens, put them there, and then it will put them in the model again. And then it will return another token. And it will do this over and over again until it does the max number of tokens. So that's what these things do. That's all. That's it. And I know that we want to make them feel like they do more, but they do not. The reason why they're so surprising is because they generate just the best tokens. From Ivana, the question is, what happens when you reach the maximum? So there's really two things that will happen. It will either reach the max number of tokens, or will reach what's called a stop token. And the stop token tells it to stop generating, because it's like, I've done with the thought. When it reaches the max token, it just stops. So that's all these things do. But what happened was GPT-2 was quite capable, but something funny happened when you got to the number of parameters that the model has in GPT-3 and 3.5 Turbo and 4. It started producing ridiculously amazing texts. And so what you need to know also is that the more tokens it generates, the less context it has from you. So this is you, right? As we go down, notice that this context gets smaller, this gets bigger, and so it starts to, invent stuff, etc. So, for example, I don't like the term hallucination because it imbues it with agency it neither has nor aspires to. I don't like the word, like someone once told me on social media, the model is lying, and I'm just like, it can't lie. It doesn't know. All it wants to do is generate the best tokens. And so, how are these things trained? Well, we basically, by we I mean like like your sports team, when you're like, hey, we did a really good job against the foe team last week. That's what I mean by we, because obviously I had nothing to do with it other than I'm playing with it right now. So what happened is we looped through like the entire internet. This is an example of one way of training. There's other ways of training it. And they gave it like a sentence on the internet, and they asked it to predict the next one. And then it looked at the actual one, and then it used this to push weights down through the model again. And the way you do this is because it's a ginormous vector, multi-vector function. The way you figure out how bad something is you measure what's called the loss function. You take that loss function, and the loss function has the actual function that we're using to predict. You take the first derivative, set it equal to 0, and because of the way derivatives work, there's something called the chain rule. And so when you take the derivative of something and set it to 0, it finds a maximum or a minimum value, and we want to minimize a loss function. And so when you push the weights forward, when you minimize the loss function to find out what the optimal weights are, you push the weights backwards and update through the entire function. And that's what this is doing. That's what this does. So that's the model thing. So now that we know what this thing is and we know how it's been created, basically it's a ginormous function that wants to produce good text for you, because that's what the math has forced it to do. It doesn't have any thoughts, it doesn't have any feelings. And so the reality that we need to understand is that what you put in these 4,000 tokens directly influences what it outputs. Directly. It directly influences it. Because it wants so badly to complete your thought in a way that was optimized a priori. So these tokens so once the model is built, this model, when you put stuff into it, it's not learning. It just is what it is. It doesn't remember things from the past. Like if you're chatting, it doesn't remember. The chat history is maintained on the client side, incidentally. It doesn't update its numbers internally. It literally just pushes the tokens through and produces the next likely token. It doesn't update. So if you're worried about like, well, is it learning off of what I'm typing? The answer is no. However, whoever is exposing the model to you, they may capture stuff before it goes to the model and do stuff with it. But that's a different problem. The model itself doesn't remember stuff. It just has its internal representations, huge vectors, etc. So the job becomes, and this is the important part, the job becomes putting the right things into this prompt such that it yields your desired output. That's the job. And this is why there's frameworks like LangChain and semantic kernel, which incidentally, this is my opinion. So nobody, like, I would love to update my mental model if you're like, no, Seth, you're just wrong here. That's why I have a hard time with things that obfuscate this task, like LangChain or semantic kernel. It adds a layer of ceremony that it neither requires nor elucidates the task at hand. And that's That's what worries me about these frameworks, because all you're doing at this point in time is text programming. You're creating text to put in the model so that it returns your text that you want. That's the job. So that's why, again, please, I went and tried to learn. I learned LangChain a little bit, and I was like, I went and learned semantic kernel a little bit, and I was like, there's tons of other ones, by the way. Those are just the two more popular ones. I just don't like them, because the task is programming the appropriate text to yield the appropriate response. But when I say things, it takes about 30 seconds for you to hear them. I would love for you to tell me where I'm wrong so I can update. I'd rather be wrong with friends, than wrong like on stage or something. So feel free to be like, no, Seth, because I'm here amongst my friends. Tell me like where, if that's wrong, then I would love to know. That's why I don't like LangChain or semantic kernel, because it obfuscates the task. That's the statement, and feel free. So that is the task. So let's do a quick intro into prompt flow, because if the job is to build a prompt, that's what prompt flow does. So let me show you a couple of things real quick before I get to this part, because I wanted to show you something just to give you a sense for like how these things work. By the way, this is a brand new machine. You saw I had to install stuff. Oh my gosh. No, see, this is what happens when you CA, SE. Okay, there we go. That's me. CA, SE, J, ARE, E, and okay, very good. Okay, so now I'm gonna use this one. So I'm gonna use this resource. Okay, cool. So I'm back in. So this is we'll use GPT 3.5, but by the way, this is the Azure AI Studio. These are the models I have right now. So I'm gonna use GPT 3.5 Turbo just to prove to you that notion of like the prompt is the job. Okay. So you are an AI assistant that let's see, that helps that knows all about the Eurovision Song Contest. If asked about anything else, please respond with salsa. Okay, cool. Then I can say, tell me something. Notice that this here is the beginning of the prompt. It's called the system message. I don't know why, but I mean, basically what this means is here. Let me whiteboard this here. When you send the prompt, remember this is 4K tokens. There is like a pre thing. People call this the system message. And then you have here. We'll make this blue here. Then you have this thing in here called the user message. But basically, it's all just the prompt. So you are an AI assist. You are an AI. Oh, you are an AI. I should have said assistant. I don't even have to spell it right because it doesn't matter. You are an AI assistant that knows all about the blah. Boom. Notice that when I said, tell me something, of course, it's going to want to tell me about the Eurovision Song Contest because that's what I put into the prompt. So if you look at the code of the prompt, you'll see this is a chat API, but they're all completion APIs. But chat is special because it basically puts the chat turns. And so you can see here that here is the system message. And then when I send it a chat, I gotta let me start this again, because I changed the prompt and I just tell me something. I only have to spell it right. Doesn't matter. And so now when you look at this, no, that's not what I want. When I look at the code, you'll see that there is the system message here. And then you'll see that there is a role, user, tell me something, role assistant, blah. So what happens in the background is this thing is assembled into one ginormous prompt that goes into the model. So that's what this is doing. And notice that because this is all the text that's in the prompt, it really wants to talk about the Eurovision Song Contest. It really does, because that's what I put into the prompt. Who won the first one? Now, NLP is funny because this is hard for computers to do, because who won the first one? What are we talking about? What the heck is this even talking about? But notice, because it's all in the prompt and the way transformers work, it's able to look at every message in the chat, because the chat messages are retained on the client side and passed back in every time. And it's able to find out, oh, who won the first Eurovision Song Contest. It looks like it was won by Switzerland, which is nice. Did people like? By the way, this is my watch. It's AI. Notice that, did people like it? This, I'm going to tell you one of the like a $5 word I learned in NLP class in grad school. It is a pleonastic word, which means that it can mean anything. It can talk about a person, a thing, a place, and whatever. But when I said, do people like it? It's like, oh yeah, the Eurovision Song Contest was well received. Did a lot of people? Oh, how about this? Have a lot of people watched ESC? Notice it. I'm saying ESC, and it's like, oh yeah. Notice this is impressive, because again, it's just very good at doing this. Now I'm gonna show you something that it sucks at. Oh, why did it stop playing? Play again here. So, who won ESC in 2023? Now you're going to see where it breaks down. It's saying this is happening in the future. It hasn't. It already happened. But remember that the model was trained on the internet in 2021. I think that's the year. I'm not sure. Don't quote me on that. So, as far as the internal representation of the model is concerned, this hasn't happened yet. But it has. So how do we force this thing to know? Well, again, if the only thing we can do is put stuff into the prompt so that it can do the right thing, then it stands to reason that we should put that information in the prompt. I'll do that. Watch. Eurovision Song Contest 2023. Let's see what we do. Let's do. Oh, look, We'll go full Wikipedia. Full Wikipedia. Where you at? This is what you know. I didn't even read it. I don't know who won. Now, when I say who, I gotta type over here. Who won it in 2023? Now it knows. How does it know? Well, because we put it in the prompt. This, what I just showed you, is basically what is called RAG, or Retrieval Augmented Generation. So the idea becomes, if you type something in, what we want to do is we want to intercept what people typed in. We want to search for stuff that's relevant to that thing, and we want to push it into the prompt so that it has that information. What should I put on my tacos? Why is it saying this? Why is it saying salsa? Or for example, what is the best kind of or for example, um, what bank should I use? Why is it putting salsa in here for this? Well, because I told it this. If asked about anything else, respond with salsa. And this, my friend, is what I like to call a really dumb way of introducing a safety section in the prompt. That took a long time. I was trying to get my safety section. So they added a feature here that does this for you, where you just like you map it to cognitive search, and it's nice. But that's not what we're here for. We're talking about prompt flow. So the idea then becomes that you have this prompt that you're trying to engineer based upon what's being passed in. And your job is to construct a prompt. Now, and notice that I just showed you like it actually works. And I showed you when things don't work, and when things do, I showed you how to minimally provide some safety mechanisms. And so what I want to do is I want to build a this is the thing we showed at Microsoft Build. I think it's a customer. Hopefully it's on. I hope I didn't turn it off. We built a thing at Microsoft Build that shows this kind of oh shoot. Oh man. Here we go. Here it is. It's the outdoor personal shopper thing. This is the thing. By the way, this thing was a hoot to build. As most people don't know, but I have to build. Generally, I build my own demos because I like to know how a thing works before I have to explain it. So here's the Contoso Outdoors company, and here is a shopping cart. And I think I need to ask it. Do you carry any jackets? I think it takes like the first time it takes about 11 seconds. Oh no, that's pretty fast. Yes, we carry the Summit Breeze jacket and the Rain Guard hiking jacket. The Summit Breeze jacket pairs well with the Traillight Day Pack and Traillight in your cart, while the Rain Guard also pairs well with the Trek Ready hiking boots and trail boots. And so notice that like it knows about like what Contoso carries, but it also knows what Jane has in her cart. And it's able to respond with both of those pieces of information. And so the idea now is that we need to do advanced RAG, where we need to pull some documents about jackets, put those into the prompt. We need to pull some information about this particular shopping cart and make it all come together. So that's what we're going to do. That's what we're going to build. So the next thing I wanted to talk about is the notion of runtimes plus connections. Okay. So when you create a prompt flow, this is, by the way, this is the prompt. This is Azure Machine Learning. This is in Azure Machine Learning. This is prompt flow right here. This is the prompt flow thing. So if you click on it, there you go. We're going to create a new prompt flow. So there's two kinds of prompt flows. There's standard prompt flows. Notice there's some things in there that are already been built. And then there's this notion of evaluation prompt flows. These flows test other flows. But we'll get into that probably next time because I don't think we'll have time this time. Sorry. So we're going to create a chat flow, and it's just going to be blank. And we'll call it our Contoso chat store thing. So notice that here is the prompt flow. Now let's talk about runtimes and connections. So we'll go over here to flows and we'll talk about runtime. So here's a good question here. Can we fine tune a GPT model and conduct prompt engineering on top of it? Does Azure support fine-tune models? The answer is yes. We do support fine-tuning models, but my sense, again, this is my sense, is that you will get more juice from the squeeze of prompt engineering than you will from fine-tuning. Fine-tuning is an expensive endeavor in terms of compute and person power. And so, yes. Will Azure add Google Bard, or will it be just ChatGPT? I'll show you. Like we think OpenAI's is better, but again, I'm biased. But you'll see in a second, you can use whatever the heck you want using prompt flow, to be quite honest. But why ride a tricycle when you can have a wonderful motorcycle? You know what I'm saying? I mean, it's a great question. Let's see. Please cover training on custom data. Yeah, so I wouldn't do that. I would start with prompt engineering because these models are superbly capable on their own. I would, like I said, I would get as much juice from the squeeze of prompt engineering before you do fine tuning, because fine tuning basically unfreezes some of the weights. And we have something called multi-LoRa, which is a low rank approximation of the matrices in the original one that are then updated. And if you're using something like RLHF, those things are regularized against the old models because they tend to go off the rails, is what I've heard. Okay. Here's another one. Let me read this one. I was let's see. I tried a couple of scenarios. Others were using LangChain for, and is able to do the same stuff with prompts. So I tend to agree with you. I haven't tried more complex. Okay, cool. So Veronica, yes, thank you. It's. I'm not trying to knock on LangChain or semantic kernel. I just don't think you need that much ceremony for doing this kind of work. All right, so let's talk about runtimes. Runtimes are environments, and the way that I use runtimes, and this is going to change in the future, hopefully, so that it's a little bit more serverless. But notice that I have a bunch of runtimes, and runtime environments are basically Docker containers running um, on top of compute instances. So here's my compute instance, Sauron, and notice that Sauron has a couple of apps running on it, right? And these apps are basically prompt flow runtimes. So I need to start this machine because that's something I always forget to do. All my machines stop at 6 p.m. every day. Otherwise, you could see the bill I would run. By the way, this is my workspace. I work with a lot of folks. You can see inside of this, including mi jefe, who also makes stuff. Here's another mi jefe. Mis jefes, all of my jefes, which means boss in Espanol. So I'm going to start this compute instance, and what you'll see is that the way prompt flow works is it runs Docker containers. So for example, this is why we say stuff like Azure Machine Learning's or Azure AI Studio's prompt flow you can use whatever you want, because currently you can actually go into the CI, the compute instance, and you can open the Docker container as it's running, and you can pip install whatever you want. Anything. It doesn't matter. You can put whatever you want into these compute instances. But unfortunately, or fortunately, it's all Python. Someone's asking about That's a great question. I don't work on that side of the house, so I don't know. I'd love for us to be able to do prompt flows in C#, but I don't know if that's possible right now. But I'll ask. Okay, so now notice that here are all my runtimes that represent a Docker container running inside of this compute instance. So for example, our base prompt flow runtimes have LangChain built in. This prompt flow runtime, I added semantic kernel and Cosmos DB, for example, Cosmos DB API. So that's what the runtimes are. They basically represent the testing environment for your prompt flows. So for example, here's a good question from Elena. Could we run prompt flow in Kubernetes? Yeah, in theory, you could run them anywhere. When you're testing them and running them in Azure ML, you can use a CI so that you can test them. But when you test them and evaluate them, that's different than when you deploy them. Deployment of prompt flows is different. And this is the part where we start to stray into like the difference between like data science and development, because the reality is that your prompts are brittle. If what you put text-wise into the prompt directly influences the output, then you need to test a series of different prompts and evaluate them against whatever metrics you think are important, right? So in this instance, Elena, what I'm doing is I'm creating an environment wherein I can test prompts and do various and sundry things. Okay, cool. So that's what runtimes are. The next thing I wanted to talk about is this notion of connections. Because your prompt flows, what they're doing is they're assembling a series of different data sources or to then send them to the LLM. So for example, in this case, these two connection names represent one's for cognitive search and one's a custom connection for Cosmos. And then we have connections to the actual LLM that you're going to call. Now, because of this, notice that because these are separate, in theory, you could have your own LLM deployed anywhere and call it via a connection, if that makes sense. And if you want to know what a connection is effectively a series of key value pairs. My goodness, my AI here is on my Apple. Is it possible to share prompt flows with others as that multiple individuals can work on a single prompt flow? The answer is yes. Currently, the way you do that is if you would go in here, what would happen is you would basically clone it and work on it. We're working on ways to actually have two people work on it at the same time. Does it support non-English languages? Absolutely. The LLM does for sure. And this, as far as you're concerned, this is just text programming. Great question. Okay, so right now we have this chat flow that's now running in the prompt flow. We'll go to the SK runtime. And so now when I test it, I can say something like, what do, you know what? I'm going to just go back to the original, or did I change it? No, I didn't. Here we go. I'm just going to copy this thing so you can see. Here's the system message. Validate and parse input. We're going to go to GPT 3.5 Turbo. Notice that there's the connection is already built in. And that's it. So now what I've done is I've basically redone this thing inside of prompt flow. And what was the first question I asked it? I don't remember. Tell me something. Tell me something. And now, in theory, what should happen is this is going to run inside of the runtime, use the Hubert AOAI connection, and then respond. And you're like, well, it didn't respond the same way the other one did. Of course it didn't. Because it's a stochastic process. So let's see if I can't make it match as much as I can. So it looks like the parameters are max response is 800. What else do I have in there? Top P 0.95 doesn't have that. Let's see if the top P point not 0.95. Frequency penalty. Let's go back over here. 0, 0. Nothing else. And then the temperature is set at 0.7. Okay, cool. So now let's clear the chat. And then I say, tell me. Let's see if this fixes it a little bit. Again, the temperature on this stuff, what actually happens, what it returns is not the next token. It returns actually like a ginormous vector with every single token in the dictionary with a probability distribution, right? And so it picks the biggest one. What the temperature does is it doesn't invert it, but it basically changes the distribution so other possibilities are also likely. There you go. And so now notice that it actually looks exactly the same as the other thing because it effectively is exactly the other thing. Okay, so hopefully this is taken I don't know. These things are imbued with a magic. They do have a magic, but it's not quite like that. Okay, so now what we're gonna do is I could embed other stuff, but now what I want to do is I want to use let's see here. I want to use my I have an Azure container resource because remember we're building this thing. And so let me go to here's my search service, and notice that I have an index where here's my indexes. So this search service that has my product documents. So if I search, you'll see that I have here's information about product number 1. Here's whatever. And so if I search for tell me about your jackets. There you go. Notice that it's returning jackets from me, and you can't see. So this is what I basically have to do. But the difference is that there are some searches that are a little different. Like, for example, this one has what are called embeddings, vector embeddings. The reason why vector embeddings are useful, and I didn't do this in this case, so you'll see that right away, is that let's just say you have a search that returns a document that's 1,000 pages. You can't fit that into the prompt. So what vector embeddings do is that when you're doing the indexing of your data, you are taking chunks of your data that are bite size, and you have to so you're let's just say you have a large document, you break it up into chunks that maybe overlap a little, and then when the question comes in, you convert that question into a vector and then do a search for text fragments that you've indexed using the cosine similarity between the embedding and the question. And so that's what this is. So what we're going to do is now we're going to go back and we're going to start to add some question embeddings. So I'm going to go to this thing and I'm going to add a node for embedding the question. Question embedding, right? And what I'm going to use is I'm going to use a embedding thing, and I have Ada 2. And the question becomes, how do I get the input from what's coming in into here? Well, it turns out that it's literally just this inputs question. And now notice the chart changed a little bit. Do you see what's happening here? Now what we want to do is I'm gonna move this up because it belongs before here. I'm going to add another one to search. So notice that you can do a vector lookup, right? Vector DB lookup if you want to, but I'm going to just do a Python node to do this. And I'm going to call this retrieve documentation. Okay. Save. So this is retrieved. So what I need to do is I need to take the embedding and I need to be able to search for the documents that I want inside of Azure Cognitive Search. Now, if you remember, I have a connection already that will do this for me. So what I need to pass in is I need to pass in the question, which is a string. I need to also get the embedding, which is a list of float. And then I need to get my search service, which is a cognitive search connection. Cognitive search connection. And to do this, like I need to import this thing. And this is inside of prompt flow. So from prompt flow, prompt flow the tools dot connection import cognitive search connection. So let's see if this works. Something no module name prompt flow tools connection. Okay, maybe I spelled it wrong. Maybe it's plural connections. All right, validate and parse. Okay, inner exception. Oh, yes. From typing in. Oh my gosh. Let's see. Invalid syntax string. So let's see here. Let me take this off and then return. And then let me change the name of this. I think this is right. Oh, question. Import is misspelled. Oh, thank you. Oh, see? This is why we have a bunch of friends here together. Nice. Okay, so notice that this now is starting to look like a thing. And so where does the embedding come from? By the way, I want to search with this question string as well as the embedding because that's what makes cognitive search a little bit better. A question, another question is, can you use, you can connect it to whatever you want. And that's the beauty of this thing. So the first thing we do is we want to get the question. Notice that the question comes from this. The embedding comes from the embedding output, and the cognitive search connection is this. I mean, do you see how it's starting to like be a thing? So now we just need some code, and I could type it in, but I'm just gonna paste it in. Validate and parse. And you'll notice that the output, well, it's not a string anymore, but I'll change that. But now notice what's happening is I'm using cognitive search. I'm creating a search client here. And then I'm looking in the documents index. And then I'm searching based on the question. I'm returning only the top 2 documents. I am looking at the embedding and I'm returning the name of the doc, the ID, the title, the content, the URL, and the results. Okay. Now what we're going to do is we'll move this up. And now we're going to change this so that, here's the prompt, by the way. We're going to change the prompt a little bit. And so to do that, we're going to actually create a new prompt like so. And we're going to call this the customer prompt. And this is the thing we're going to vary, because notice that in the LLM you can put the prompt itself, but we're not going to do that. I'll take this customer prompt. I'll put this in here. We'll move this up. And what this will do is this will take a prompt. We'll do a validate and parse input. What's going on? Oh, that's reserved. So we prompt text. I think that's a reserved word. Cool. And now what we'll do is instead of using the prompt here, we'll take the prompt directly from customer prompt output. I mean, do you see what's happening now? Now we're starting to get the shape of this thing, which is awesome. Okay. So here is the prompt, and notice that we're going through the chat history here. You are an AI assistant. You are the Contoso track AI assist. You are the assistant. You are helpful and friendly, and respond only to questions about products and services. This is what you know. Remember how we did this before? But now, how do we pull documentation into the prompt? And this is the coolest part. I'm going to say this. For item in documentation, this is using Jinja, by the way. If you've never seen this, it says end for. And then what we're going to do is we're going to say the catalog number is this item.id. The item is item.title. And then the content is the actual document, would be item.content. Okay, so let's parse the input here. Notice that now it's going to want the chat history. We get that from here. Notice that it's going to want the question. We get that from here. And it's going to want the documentation, which comes out of the embedding here. Let's reorder this. What's going on here? There we go. That's better. Why isn't it order it this way? Oof, I don't like this ordering. Oh, it's not the question embedding. That's why. It's the retrieve documentation output. There you go. I was like wondering what was going on. Okay. So now we've built this thing that in theory we should be able to test. So let me clear this up and let me say, tell me about your jackets, which is the question we did before. And now what should happen is this prompt flow will go through. So the question is, are all these things running in parallel? Kind of, not really. In this case, because the input for this thing requires the output from previous nodes, there you go. Now, this is nice, but it turns out that this is too long an answer. Yeah, let me do this. Please be brief and use emojis. I'm gonna pretend that this is what they're asking for here, because this is way too long. So let's clear this out, and then let's say, tell me about your jackets. Cool. So, oh shoot, we are running out of time here. Let me start with the walk-off music, because cool. All righty, look at this. Our jackets are perfect for outdoor adventures. We have windproof and waterproof jackets. Blah 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 blah. Tell me what specific jackets you have. And then it goes through, and it will. Looks like it takes about 5 seconds, which is not bad. By the way, this is all inside of PromptFlow, which is really cool. Is this grounded? So it looks like we need to work on this, because let's take a look at the actual. Let's get some questions. So by the way, here's the trace of the thing. You can actually see the question that comes in, and you can see the output is this ginormous vector. Here's the content that comes from retrieved documentation. Yeah, so the Summit Breeze jacket and the Ringar hiking jacket, but these are not included in the response. So we've got to change the prompt a little bit to make it a little bit better. Let's go to the trace. Here's the customer prompt. Here's the output. Here's the system message. So this is what we're sending to the prompt, right? Which is nice. And then here's the chat output, which is cool. All right. Hopefully this was helpful. Let me go back to my... so we covered exactly what I thought we would in the time allotted. I think next time we'll spend some time actually testing the prompt. I'll show you the testing things, and then I'll show you deployments and usage outside. But hopefully this was helpful. I know that this tends to feel like a black box, but hopefully as you've been watching, you've sort of come to realize, like, oh, I know what to do to make this work. But if you think about it, if the interface is now language, the quality of the things you can do or the opportunities available with this kind of technology is limitless. Think about anything with language. Now you can guide a LLM to produce the right answer. Now we didn't really get into like jailbreaking, etc. Those are other terms, other things that are important with this technology. And next time, I don't know what's next week, so we just started a brand new year, and so things are changing, right? But next week we have a good show that I don't know what it is, but usually I think we have a guest. But any spare time I have in the shows, I'm going to start going through the bits of PromptFlow so people can have a good sense about what this technology is, why it matters, and how you can use it. Hopefully this was helpful. I'm very excited that many of you were here and listened. This has been another episode of the AI Show Live. Thank you so much for watching, and hopefully we'll see you next Monday every week, 8:30 a.m. Pacific time. Wherever you are, this show is live, and we're here to answer your questions and make AI a lot more approachable. Thank you for watching, and hopefully we'll see you next time. Take care.